Okay, we're almost done. So thinking about everything we've covered for all of chapter 4. Remember, we did all this to get more bang for our buck. Before virtualization became a reality for us, before VMware did all the heavy lifting of making this stuff possible, and then a number of other folks got into the business as well. We've talked about VMware, we've talked about VirtualBox, we've talked about Hyper-V. I've mentioned parallels in class. We've talked about some of the open source solutions, things like KVM, QMU, Virt Manager, etc. The typical server was maybe using 50% of its capacity, still generating a lot of heat, still pulling a lot of power, still taking up a lot of space, but really only doing not a whole lot most of the time. The data center has a lot. Now the data center with virtualization, we can build more VMs in the same physical, more machines in the same physical space by virtualizing them. Moore's law has helped us a lot here. Um, Memory gets smaller and smaller and smaller physically. I mean, actually, it stays about the same size physically, and gets massively more capacious, shall we say, in terms of storage. Think about if ask someone who's been in this business for a long time what the oldest data stick they remember is. In my case, I can remember thinking that that $8 or $10 for a 4 gig or 2 gig data stick was a really good deal, and that's within the last 10 years. It's changed massively in that time. Because we can build better computers with more memory, more processor that's supporting more concurrent VMs at the same time. Abstracting not just storage but also networking. That brings us to hyperconvergence. You can virtualize the computers. You can virtualize their storage. You can virtualize their networking. You can virtualize storage area networks with vSANs. That gives us the ability to do things like virtual switching, vSANs, clustering, with VMware, distributed resource scheduling, vMotion. So we can move these things around in the data center from one ESXi host to another in real time without shutting anything down. Now, the unfortunate thing is that creates attack surface. Every layer of abstraction, up to and including the GUI, is a potential vulnerability. So we have to think about extra security, extra data security, so we don't lose any data in backup, because literally the entire data center is data that needs to be backed up. That gives us some implication that involves things that we have to think about in terms of our operational security. We have to monitor that virtual network just as well as we have to monitor a physical network. So you're going to need virtual firewalls, virtual UTMs, virtual IDSs, virtual DLP. And of course, you also have to do some human resource policy things, separation of duties, mandatory vacations, job rotation, all the things you may have or will talk about in terms of security policy in other classes applies here. And of course, the same things that we know about malware remain true. Your end hosts may pick up viruses, worms, trojans, spyware, but there may also be malware attacking the virtualization platform itself, attempting VM escape. So you need to think about everything, scanning that network. Make sure that even your virtual systems have host intrusion detection, that on your virtual network, there's, if possible, say for example with Hyper-V's virtual switch extensions, if you can add anti-malware or firewall capabilities to those virtualized switches, you can do that. You can also simulate these things. So add whatever you would need to do as far as your firewalls. Of course, thinking in terms of things like your segmentation. maybe even segmentation in terms of firewall rules for things getting in and out of your virtual SAN. What kind of traffic will flow through the management network, and think about having not just those virtual machines not tied into not just one network, the network through which they'll feed their services to the end customer, to the end user, but a management network, so that Hyper-V or vCenter can manage those hosts. The vSAN that they're all talking to, the vSAN that's all supporting them. So you've got your data vSAN and maybe another vSAN that's basically just supporting all your VMs. This can get very, very complicated. So think very clearly about what traffic should be on each of those networks and how much you can firewall things off from each other. We're always going to seek to apply the principles of least privilege and the principles of fault tolerance and redundancy. You want to make sure that no one piece of the puzzle can break every other piece of the puzzle. Say the loss of one piece of the system will not bring the whole system down, the single point of failure. And also making sure that even your systems, not just your users, but the systems themselves, have just as much, have just enough to do their work and nothing more. In the next chapter, we're going to talk more about, next couple of chapters, we're going to talk more about Hyper-V and the Virtual Machine Manager, before finally getting back to VMware in chapter 7, I think. Well, anyway, thank you for watching, and I'll talk to you soon.